Cool. So I think I have to start with an apology. I think I met some of you earlier. I didn't introduce myself. I'll take the time to do that now. Hopefully it's fine. My name is Radu, and I'm a senior engineering manager at Atlassian. And my talk is about how we broke into Devops. It wasn't by choice, it was by need. And to showcase that, I'm going to share with you a short set of cautionary tales. But before we go there, just a bit more about myself so you get to know me. I've been working as an engineering manager for almost 8 years now, going on 9. Hopefully I make it 10. I work in many capacities. I've been initially trained as an engineer, so coming a bit from the other side of DevOps, more dev, less ops. So really keen on the work to transition and actually make working code for real customer use cases. I also work the hat of a Scrum Master, data analyst, product manager. I think these all come at the confluence of engineering management. In terms of past experience, I worked in Amazon and fintech companies across the world. And my personal mission is to fuel products, teams, and individual growth for people, for great products, and for great users. Before we move forward, I'm curious about yourselves. And by show of hands, who has been practicing DevOps or has been close to DevOps for 3 years or more? Thank you. Any more? Yeah, that's good. Cool. Watch out for these folks. We have networking. Go ask them questions afterwards. Thank you for the extra presenters. Is anyone here implementing DevOps or adopting DevOps practices in a startup environment? Okay, wonderful. Okay, cool. So hopefully all the stuff I say makes sense to some. And anyone here having an embarrassing experience they are happy to share, not publicly, but maybe in the networking session, so they don't leave me hanging with just my three. Well, there's pizza, there's beers, the wine made you make courage. So thanks for everyone that was happy to share. As a present, I can also share what I'm working on myself. So as you mentioned earlier, I'm part of Jira Service Management and closely more onto Assets. Assets is one of our XMDB solutions. It can also be a CMDB, but I heard it's a 4-letter word. And we store entities, and we are able to store these entities across widespread of Atlassian products. So it's a database, essentially, and it's very powerful because it connects with incident management, change management practices. It can also connect with development. I think it's a good segue to meet the worlds of development and operations through Atlassian solutions. Definitely there's other tools out there. I encourage you to check it out and see what fits best. Before we jump into today's examples, I do want to share one great resource I found myself, and that is the Google SRE Handbook. I think it's a great place to start if you are diving into DevOps or breaking into much like we did. And if you are experienced, I think it's a good fundamental refresher. It's quite long. The value I found from it so far is that it connects the theoretical aspects that engineers implement with the practical aspect of operations. And amongst the initial pages of the book, you're going to find out that at Google, SREs actually work part-time on code, creating those automations, creating those changes based on emerging patterns or on spikes. Like Black Friday is across next week or this month, so you're going to expect that some companies are going to need their SREs to prepare the systems. Also, as companies grow, the customers exhibit different patterns of usage. Maybe they are looking more after API usage than the UI. So probably that's a space for an SRE to jump in and say, look, the real life use case for this application has changed. As a consequence, we need to go back and rethink the code that we've done. So really great place to start. I found it useful. I'm still going through it. I'm still taking my teams through it. And I encourage you to read it if you haven't, or think about it next time you have a problem. Now for our talk. This is where we're starting. But before we do so, and I saw earlier that you had a similar topic on how Jira went from server to cloud. I do want to touch on the same topic. For me, it's sometimes like moving house. So there's a lot of stuff you need to move from left to right, and sometimes they don't even end up in the same shape or form. This happens a lot. And I think it makes a lot of sense. Within the past 15 years, a lot of companies made this transition from initial server solutions to cloud-based ones. And that makes a lot of sense. Business grows, patterns change over time. But oftentimes the solution that an engineer implements in server needs to be different in cloud. And that's very deeply rooted in also how computers are made. So if you think about, on the motherboard there's a processor and there's a RAM. And there's a very fast communication buffer between the two. Now you also have a hard disk or a GPU. The communication with those things is slower. And even more so when you think about input and output devices like the Ethernet cable or Wi-Fi or Bluetooth. These medium is even slower. So depending on where the application or where the solution or the implementation is done or what pieces of hardware it uses on the machine, it has to cater to different response times, to different storage capacities. And similarly, this is happening in our cloud world because cloud machines are separated, are distant from each other. We always pay a latency cost. We always have issues with one node coming up or one node going down. So it's a change, a shift in paradigm, and it's a shift in solutions. And oftentimes we leave these behind when we move our solutions to cloud, and then we pay the cost in operations. That's not to say that one is better or worse than the other, but it's a shift. And I'm not going to go too much in detail on this. I think, in my opinion, in server world, you have things which are strongly consistent, so you have quick access to information because they're co-located. While in cloud environments, because you could be talking to a server across the world, things are eventually consistent from a perception standpoint. So how do we change our features? How do we change our application to cater to these things? And similarly, because server has a great power of being tight-knit, being close together, it's also a single point of failure. If your power source runs out, your whole system is down. Everything you have is down. Whereas cloud, it's a bit fault tolerant. You can bring up a new node or just a part of the system fails. So having this in mind, that's how I approach thinking about DevOps. That's how I approach about thinking of changing applications that were initially created on server and moving them to cloud. And these are going to come back into some of the examples that are going to come later. Cool. Now, I think I forgot my mug over there, but just to give me a bit of a breather, think about whether your deployment or whether your solution is giving you any pain because it was implemented using server principles as opposed to cloud principles. You might be suffering from that. And there's no way to easily change that. It just needs a lot of signals, understanding where the problem is at and how you need to change it. But you might be suffering from that as well. Cool. So going through the first examples, I've been in Australia for 5 years so far, and I'm learning a lot of new words. One of them is foot gun. And essentially, it's the act of shooting yourself in the foot by doing something which is questionable. So I'll be sharing a few examples of how we treated incidents. There are some questionable actions there. I'll let you find out the theme, and we'll draw a conclusion together at the end. So the first example, which is going to appear probably in this area, but after I tell you about it, it's about an incident we had. So we noticed that some of our customers were not getting responses from our service. And upon investigation, we noticed the adjacent and supporting services for authentication, for routing were not responding. And consequently, our whole application was failing. We fixed it, it was all right. And as we fixed it, we found out that 3% of our adjacent services were restored off of corrupted distributables. So the image, the base image that we were putting on the machine, right, fault tolerant and cloud and resilient as they were, the base image was corrupted and wouldn't work. Now after we fixed it, the team decided to put in an alert if anytime in the future there would be a problem with customer is not getting responses, we would get an alert. So, yeah, that was the first incident. Now, the second incident started with noticing that customers were not getting access to the data. The service was going fine, the UI was loading, but they wouldn't get any data from the backend. And the reason is, as I foolishly clicked, we had saturated DB connections. So we made a change, we rolled it out to production, and then we were not relinquishing the threads for database connectivity, and as a consequence, new customers and new instances wouldn't get new threads. We fixed it with the DB connections, and we realized that we should put in an alert whenever new DB connections would be saturated and we wouldn't be received. I think you can probably spot the trend by now, but just to hone that in, I can go with a third example. In the third context, we had an issue with hydrating our service. So our service kept a lot of information in our cache, and we had to acquire it from the database. Now, we weren't responding to customers, and the reason was that we'd never finished hydration of our service. And wouldn't you know it, the hydration didn't work because there were no more DB connections. So we fixed the problem. And what we ended up doing was add an alert whenever the hydration wouldn't finish. So 3 different problems. We always added an alert at the end, which told us to investigate. And as you might notice, the third incident should have been caught by the alert on the second incident. What do you think happened from here on? Well, the team had the same pattern of solving incidents through adding more alerting. And as time passed and as we solved more and more incidents, we had 1 alert pop up. Then we had 2 alerts pop up. And then we had more and more alerts. And it was fine. Actually, no. Part of Devops is also ops, which meant that this ate a lot with a high ops budget, that we had to investigate everything every time. We had noises. So we realized that instead of adding more alerts, we should have looked at root causes. And we shouldn't have let some of these things pass. Now, granted, there were some challenging aspects about our architecture at the time. And in a crunch, you sometimes make suboptimal decisions. But they caught up with us. And when we noticed this high level of alerts, we decided to go back and fix the root causes. So fix it right and avoid alerts as much as you can. And a tip that's not here is try to fix the root cause and have a runbook. Try to have as few alerts as possible. Humans are important. You're all important. You don't need to spend your time doing investigations every time alert. So that was number 1. For number 2, and before we go there, we'll take a bit of time to share a bit more about myself. Let's see if I have the space. I think, in short, when I was a child, I tried to learn many things. My parents took me to sports, chess, one of them. But the other thing that they took me to was trying to learn karate. And I came back one day trying to impress my mother that I learned something. And I told her to hit me. It was on purpose. And I assumed the guard position. And naturally, she did something I didn't expect, and she went through my defenses. So I had to take a step back, educate her on how to properly hit me. And when she performed as I asked her to, I managed to block the hit. So you're going to see how this is relevant. But before we go there, don't fuck the customer. That's one of the Atlassian values. And it means that when you do something, do it making sure that it's serving the right person in the right way. And I think the question is like, who is the customer? Is the customer the end user? Is the customer the person who runs the system? Is the customer yourself? And the answer is yes to all of those, because you take accountability, you try to offer a good service to someone, and if you offer a bad one, you kind of end up bearing the brunt of it yourself. So with that in mind, we had another situation where the hydration of our services took very long, 1 minute, sometimes 3 minutes. And in that time, we could not serve customer requests. We decided to respond to customer with 4 to 9s telling them that you're asking for too many things of us, we're not ready to serve your request. And I see someone nodding, yes, you got it. It didn't work because customers didn't care that we needed to hydrate our service. They wanted what they wanted and they wanted it at that point. It was very clear that we weren't prepared for reality. Much like myself, I had to be asked or hit in the right way, like following a procedure. Customers wouldn't relent on asking us or making queries to us while we were running. So after a while, we realized that customers were complaining and we were blind to it. We did have SLOs, but our SLOs only looked at the ratio between 200 errors and 500 or 5xx's. So it means that we didn't have clarity on the customer's situation, on how well they were doing. So we ended up actually removing those 4 to 9s and being honest about the errors that we were sending and kind of adapted to reality. Much like myself, I think you learn something in a dojo, and then you go out in the real world and then you have to understand it, you have to experience it and have to adapt. Much like an engineer creates a solution, and then when you throw it out in the real world, there's post-deployment activities where an SRE shines. That's where an SRE is able to make the link and the connection between the theoretical solution to the problem that's identified and the real-life usage of people. The last bit that I have is go small or go home, but there's networking afterwards, so please stick around. We also have pizza. It's making me hungry, so I'll see what I can do about it for everyone. Our system was big, and because we had cloud deployments, you can think about all of our deployments as being cogs. Because essentially what we did was ship services in containers for our customers, and some of our customers were bigger, some of our customers were smaller. Similarly, we were making regular deployments to them. And those deployments were underpinning multiple experiences. So whenever we made a mistake, everyone heard about it. It was very visible. So that was really tough on us. We were in a spot where we had to improve our code base or ship new features. So there was the question of how we would do both at the same time. And the way we thought about it is approaching it in a risk-based manner. So we were trying to think about what would be the less riskiest type of rollout that would give us the most signal and confidence that what we're doing has a positive impact. And we were lucky because some of our customers were using our solution more or less. I faded the ones that wouldn't use it as much. So we started looking into them. So we looked at some customers and we tried to understand, well, how many customers do we have around the bigger cogs and how many customers do we have around the smaller ones? And then we noticed that in some scenarios we have different departments which are well identified, and you can think about it like the support department or HR or legal or like classes of departments that would have identity in themselves, also have like critical mass and will be highly impacted by customers. But we also have smaller groups which have a more diversified set of roles and skills, and they would be a different cohort. Now, we ended up selecting those ones, so the ones which are high usage, varied usage from our cohorts, and thought that these would be the best candidates to give us the best quality signal with the least impact when we would have a potential issue. So we went back to our results, our customers, and we created a new cohort which was based on a few of these high-intensity customers where we will notice that there would be less impact if something were to go wrong. And then we continued in that manner. So that helped us on the spot to continue business as usual as we were prioritizing and thinking about the long-term changes that we wanted to make to our system. So risk management really helps at the end of the day. We're doing really well. I want to thank everyone. This is the end of my 3 embarrassing fails for today. I learned a lot from them. Hopefully you can. And if you have any questions, I'll stick around for networking and you can ask me if you want. Thank you.